This episode of The Energy Show is proudly sponsored by Sunlight and Power, the Bay Area's leading commercial and residential solar contractor. SLP has been designing and installing photovoltaic, battery backup, and solar thermal solutions since 1976. Help fight climate change. Go solar with Sunlight and Power today.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, you read the headline, Why Utilities Won't Let You Use Your EV to Power Your Home. Well, utilities and EV manufacturers have been talking about using EVs to power homes for over a decade. They call it vehicle-to-grid, or V2G. Now, the idea uses the large DC battery in your car to support the electric grid during peak demand times and to power your house during a blackout, which I have to add is primarily caused by the lack of utility maintenance. So conceptually, the idea makes some sense, but in reality, it's a really bad idea when implemented by investor-owned utilities who are trying to make a profit. Now, I started a V2G project when I reserved a Ford Lightning truck for work. This was like 2 or 3 years ago. Now, the Lightning truck was really interesting because it had a 131 kilowatt hour battery. I could use it for work, and it had a 240 volt 9.2 kilowatt AC generator output. That's a big generator output. It's like a 10 kilowatt generator, and it's all electronic. I already have solar and a battery energy storage system at home. So to connect my truck that I hadn't gotten yet, that would be compliant with utility vehicle-to-grid regulations, I would have to install basically another $15,000 to $20,000 worth of equipment. Now, the price of the equipment is less, but there's a lot of integration work, and it's complicated. You know, when I kind of looked at this and I talked to people who had tried these car company vehicle-to-grid integration systems, I'm not going to mention the companies, but they're kind of sponsored by the car companies. The systems are so flaky that most experienced installers won't touch them anymore. So the reality of V2G is it's a utility-led effort to maximize utility profits. So basically what happens is the energy will flow from your vehicle to the utility when the utility needs extra power. And the energy will flow from the grid to your vehicle, charging your car, generally when you want, but there are times when the utility is going to say, I'm turning off your charging because there's not enough grid capacity. So essentially, the vehicle grid system's biggest loss of these things, the biggest disconnect, is that they don't allow you to use your own vehicle's battery when you want, which is during peak electricity rate times. So you can't use your EV battery to save a significant amount of money. And they make it needlessly complicated to simply connect your vehicle to your home for backup power. Power goes out, you want to use your vehicle, it's way too complicated with their system. So these crazy schemes, like this one, are one reason why our electric rates are so high. Utilities and car companies and installers just run in circles trying all these pilot programs, and they're really not that cost effective, and they're almost never going to work, at least in my humble opinion. Here's a diagram of a vehicle-to-grid system, noting the extra equipment that you're going to need for that V2G unit. Now, these systems typically control the charging and the discharging of your EV battery based on utility needs and your preferences. These systems include interlocks to prevent the use of that EV battery to power your home, except during a blackout. And they require participation in special utility V2G programs, and they're also usually very specific to the vehicle and the equipment that you install. So let's unpack the components in most V2G systems that are required by utilities. That's what's kind of on the right-hand side here. So first, it has a bi-directional EV charger that connects to the charging port of your EV. There's a grid-compliant inverter that meets the UL 1741 standards that's there to change the DC power from your battery to the AC power used by the grid and requires synchronization with the grid. It's very tricky, and it also makes sure, UL 1741, that the battery never backfeeds the grid unless the utility says it's okay. It includes a gateway. We also call it a transfer switch. Some people also call it a microgrid interface device, or MID, to connect the inverter to your home's electrical service and the utility. So this gateway has to have communication capabilities to the utility. And what this gateway does is it prevents you from accidentally backfeeding to the grid. The other thing that kind of surprised me is the systems also require about a 1 kilowatt black start battery to operate the system during a blackout. Because if there's a blackout, there's no power. They still want this thing to work. So they have to add a battery that's always going to have enough power to turn the thing on. That's all the hardware. But what's surprising in reality is you need firmware that interconnects all these components. So each component has some software we call firmware running on it. The utility has software to allow interoperability with the grid and manage these programs. And the EV companies need software in their vehicle to allow interoperability with the utility and with the home system. So there's a lot of software involved, and that's kind of probably what's bogging down the whole thing. And I'm not optimistic that's going to get resolved anytime really soon. So energy storage system industry has a tendency of drawing really nice schematic block diagrams with arrows and descriptions showing how all the equipment works together. And there's the kind of hope and the posturing that these diagrams represent a real-world solution. And I have no doubt that they can work in the real world, but you start with a diagram, and you can't sell that diagram until the hardware really works. And you really can't sell the hardware until it's UL listed for that specific application. And you really can't get the UL listing until you have the software and the firmware that's working. So when these systems are first cobbled together after some smart engineers block diagram, they generally don't work that reliably and have buggy software and firmware. They're definitely not ready for prime time. And that's why it's really a challenge for companies like Cinnamon Energy Systems and others to install battery storage systems to make sure that everything's really working properly, not buggy, the equipment's mature, and customers are going to have a good experience. So I kind of have a tendency to ignore these schematic diagrams, and I look for solutions that are really working. Like, show me a system working in the field, plug in the vehicle and see if it works. Okay, so I'm not going to go into all the gory details of this extra V2G equipment, because there's a much better way to reduce your electric bill by using the battery in your own EV and getting power during a blackout without a lot of extra equipment. And here's a simple thing. Just make sure your vehicle has a 240 volt AC output. Now, that requires the vehicle to have like a 10 kilowatt inverter, not that big, but it has to be built in and integrated with the vehicle. Once you have that vehicle with that big 240 volt inverter, it will connect directly to properly configured generator inputs of energy storage system. So there's a few companies that have really done this, kind of like this picture. Now, I drew this diagram up over 2 years ago. When I drew it, it was a lot crummier looking, so I had it polished up a little bit. But it's called vehicle to home, or V2H, and people have been talking about it. Some people call it vehicle to load. And load is a utility term for something that uses power. But the reality is, the only load that people care about when they have an EV is powering their home. Don't really care that much about providing extra power to the utility or powering really anything else. It's their house that they want that power in. So after I did this drawing, I kind of kept my mouth mostly shut until I was sure this concept would work. And now in 2025, at least one ESS manufacturer is ready for prime time with vehicle-to-home solution. And other energy storage solution companies are not far behind. I'm not going to mention names. These are very well-known, respected companies, and they're really working on this now. And the other part of it is the key, is there are a few more vehicles that are available with this capability. So there are, I can count right now, 3 vehicles that have the properly sized inverter in them that will plug into these ESS systems. And I'm sure other manufacturers are now planning to add an inverter. For the way car companies work, it's probably only $200 or $300 so that they can provide this 240 volt power. Now, there's some key differences between vehicle to grid and vehicle to home. Vehicle to grid requires a special bidirectional charger, and it requires a DC to DC converter. Essentially, it's a duplicate energy storage system. You can't use that existing energy storage system that you have right now in most cases unless it's got that generator input. V2G requires, as we talked about, special software for the vehicle, special software for their extra equipment, and special software to interconnect with the utility. On the other hand, V2H, vehicle to home, that we're talking about in my diagram, uses standard AC power from the vehicle into the house. So the V2H works with any ESS that can properly accept a generator input. You connect the AC generator output from the EV, like in my Ford Lightning, there's a plug in an extension cord to that, the right size extension cord, then plug it into the AC generator input of the energy storage system and turn the vehicle on, make sure the energy storage system is working, touch a few buttons on the app, and you're done. Now, it does require, as I mentioned, a vehicle with an onboard 240-volt inverter, but that's becoming more and more common. Now, vehicle-to-home systems with this standard AC input and output design, they're good for homeowners because they use the vehicle battery to avoid peak electric rates. They use the vehicle battery to recharge the home battery to prepare for cold and cloudy weather. So if you know that there's a storm coming, you can use your vehicle's battery to charge up your home battery. And you can use the vehicle battery for power during a blackout when the home battery is low or depleted. These systems are also good for EV manufacturers because it adds a lot of value to the EV. They'll sell more vehicles, more pickups, more cars. And it's good for the electric grid because it reduces the demand on the electric grid. I mean, it's a kind of a good thing if you're doing this, and if you're, instead of in the late afternoon, you're using utility power, you're using your own battery power. That's good for the grid. You have to be careful though, because there's a distinction between what's good for the grid and what's good for utilities. This is the V2H systems that I'm talking about are actually bad for utilities because it reduces their profits. They're going to sell less power during peak times. In my humble opinion, that's why there's so few, if any, vehicle-to-home pilots. And they're pretty much all vehicle-to-grid. Even if the utilities say it's vehicle-to-home, they realize home is what people want. It's really vehicle-to-grid. It doesn't allow you to offset your home energy use at peak times. They're only really for the utility. Okay, so now let's talk about the nuts and bolts. The trickiest thing in this whole concept is making sure that there's more vehicles that support this system. First of all, there are several popular energy storage system, home battery systems that accept AC generator input. And the way these systems are designed is kind of standard. They're designed to isolate from the grid when accepting power from your EV. So power doesn't go from your EV into your home energy storage system back to the utility. Power goes from your EV into your energy storage system only to your home. It's extremely important. This is a capability that is required under the National Electric Code and under most utility regulations. So ES systems, they have this capability. It's code compliant. Several vehicles have large 10 kilowatt range onboard 240 volt generators available. They're basically the ones that I'm familiar with. The Ford Lightning, it was designed as a contractor vehicle. So sometimes contractors may be in a remote area or doing some construction. They're going to need a lot of power. They just plug it into this generator. So the Ford Lightning, as I mentioned, has a 9.2 kilowatt generator output. The Tesla Cybertruck and the GMC Sierra or Denali also has a similarly sized 240 volt 9 or 10 kilowatt output. It's great. That's all you need. You may need an electrician to install the correct type of code-compliant receptacle that you plug the extension cord from your EV into your home, but that's not a big deal. Any electrician could do that. So at the end of the day, V2H makes it easier to reduce your electric bill. That's what you want to do. You don't want to pay high peak demand rates. You want to get power from your home battery system and power from your EV. And these EVs have huge batteries. That's enough capacity for several days of power. You can power your house through cold, windy, snowy, cloudy, rainy weather. And if your EV battery gets down low, you can always just drive to a local high-speed charging station to top off your EV during bad weather. It's magical. Basically, it becomes a very powerful, long-lasting, and convenient microgrid. So taken to the extreme, vehicle-to-home enables a concept called grid defection. I've talked about this before. Grid defection is basically when people say, hey, I don't need the grid as much, I'm going to partially defect, Or if they have a really big microgrid, maybe an EV, like I'm talking about, they can say, hey, I don't even need the utility at all anymore. Between my rooftop solar system, my home battery system, and my 130 kilowatt hour battery in my vehicle, I don't really need to pay a utility bill. I got all I need. So these microgrids enable partial and eventually full grid defection. And the way they're going to work is, first, you're going to use your home solar, use that during the day. In the afternoon and evening, you may use your home battery. And then you use your EV. And if the EV is depleted, you can usually drive to a local charging station and charge the thing up. Now, the place where this partial or full grid defection is going to happen first is mostly in sunny climates where they got plenty of solar so for the solar system, and mild climates where they don't have really, really cold winters, because what's a challenge with these systems, we'll talk about in a second, is running the heat pump at night. Heat pump's fully electric. Running that heat pump at night uses a lot of electricity. And the third criteria for where these make sense is when electric rates are really high. Basically, those are the cases where you can say, heck, I'll use my EV to avoid those high peak afternoon and evening electric rates. Hey, funny thing, it's California, Hawaii, and a few other places like that that have these criteria: sunny, mild climates, high electric rates. Now, I mentioned heat pumps. And if you don't have a heat pump, you have a regular natural gas furnace, it's a lot easier to do grid defection, because the biggest energy consumer in an electrified house is that heat pump. And if you don't have a fully electrified house, if you still have natural gas heating, it's a lot easier to do. Now, what's also available are hybrid heat pumps. So these are heat pumps that are kind of designed for really cold areas where they can have natural gas and electric heat pump capability. And if you're looking at doing some grid defection, that might be something to look into. Instead of putting in a regular heat pump like I have, it doesn't have any natural gas at all, you have natural gas backup for extended really cold nights. Now, obviously, grid defection, utilities hate that concept, but the technology is advancing much faster than utility systems and regulations apply. We can do this now, and it's something that the regulations are completely compliant with. So I take another step back and say, what would be the ideal way for us to power our homes? Well, to me, the ideal way, and it's the cheapest and fastest grid for everyone, cheapest and fastest, combine rooftop solar with a home battery system and an EV. And here's the kicker: you charge your EV up during the day at your workplace. By charging during the day, electricity rates are really low at that point. There's an abundance of utility scale solar on the grid. In some cases, there's a negative cost for the electricity. The utility scale solar plants actually have to pay not to send power to the grid. So you want to be able to charge your vehicle during the day when it's sunny and electricity is really cheap. The utility prices haven't really reflected these yet, but it's absolute a fact that there's so much power during the day on sunny days that that's a perfect time to charge. Now, also, if you're charging during the day, you may be charging for 6 to 8 hours when you're at work. You don't need a high-speed charger. You can use a level 2 charger. So those high-speed chargers are really expensive to put in because they need a lot of upgrades to the utility infrastructure for the site. Level 2 chargers, you just run those, basically with a standard, 20 or 40 amp electric circuit. It's pretty straightforward. It's pretty easy. So you don't really need a lot of electrical upgrades. So here's the concept. You drive your car to work or your truck to work, you plug it in at work, at school, at covered parking, wherever, top off the charge, drive that vehicle home, plug that EV into your home battery system, as long as that EV has that onboard 240 volt charger, and that EV is all set to provide extra energy overnight in case your home battery system's depleted. So that's the ideal grid for everyone. Now, remember, solar's by far and away the cheapest source of energy. And we talked about this before, but it's most cost effective when that energy is generated locally. Generating power on the roof of the building makes total sense. Generating power at utility scale power plants 100, 500, 1,000 miles away requires very expensive long distance transmission lines. And it takes a decade to get those transmission lines built. So we're in a situation where there's a shortage of electricity at buildings. And people have EVs. We're building AI data centers. They're putting in electrification, their heat pumps. We need more power really fast. And it's much faster to install rooftop solar than long distance transmission lines. And also, interesting, People don't talk about this, but the rooftop solar is paid by the host customer. The school pays for that power, or the government building, or the parking lot, or you pay for that power on your home. So you're not asking ratepayers to invest all this money. So I'm a big fan of combining rooftop solar, home batteries, EVs, and workplace charging. So kind of wrapping up here, here's what you can do now to get your EV to power your home. Now, first, confirm that your home energy storage system can accept power from an external EV generator. Many of the popular systems are talking about this capability. A few companies have delivered it. Get one of the EVs that I mentioned, or wait a little bit until car companies are actually putting onboard 240-volt chargers in all their vehicles. Hey, I suggest sending an email to the car company CEOs. Send the email to the CEO of Ford, of GM, of BMW, of Mercedes, of Stellantis. Tell them that you really want to get their EV to power the home, and all they have to do is add a $200 or $300 built-in generator. I suggest when you send this email, what the heck? Include the attached vehicle-to-home video to show them how it's done. And that video you can see is at www.cinnamon.energy/vehicle-to-home. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to the Energy Show website at energyshow.biz and listen to the podcasts.
This episode of The Energy Show was proudly sponsored by Sunlight and Power, the Bay Area's leading commercial and residential solar contractor. SLP has been designing and installing photovoltaic, battery backup, and solar thermal solutions since 1976. Help fight climate change. Go solar with Sunlight and Power today.